as we start working with quadratics more, we're going to have to understand polynomials. We're going to have to know how to add, subtract, multiply, and divide them. Before we can add, subtract, multiply, and divide something, we have to know what it is. So we're going to start off by figuring out what exactly a polynomial is. So a polynomial is, when we break down what that means, it breaks down into many terms. I mean, that's not exactly what nomial means, but that's basically what polynomial means. It means an expression with many terms. How many terms? We don't know. But when we actually look at those polynomials, they are given names specifically related to the highest exponent and the number of terms. So we're going to start off by talking about the names related to the highest exponent, and we call that classifying by degree. The degree is the exponent that you see above it. Okay, so if the highest exponent is 0, we're going to call that a constant. Now, what does that mean when we see an exponent of 0? That means we're not actually going to see any variables. So what that would look like is it might look like the number -7 or the number 23 or 23 plus 7 plus 6, okay? These are both expressions, okay? And they have no variables, so we call them constant, okay? Now, if my highest exponent is 1, I'm going to call that linear. So like it might be 2x or 27 minus 16x or 3x minus 2. Any of those would be called linear. And that should look familiar to you because our linear, those look like linear equations. I could write them in mx plus b format. Okay? If the highest exponent I see is 2, I'm going to call that quadratic. And that would look like 12x minus 3x squared. It might look like 5x squared plus 2x plus 1, okay? But the highest exponent I see how, real quick, going back to linear, you see how I said the highest exponent is 1? Remember, there's always that invisible 1 exponent that I could draw next to any of those x's. Here, I see an invisible exponent of 1, but the biggest one I see is 2. So I'm always looking for the biggest exponent, okay? If I see the highest exponent is 3, I'm going to call it cubic. And that might look like 7x squared minus 5x minus x to the third. Now, these are all out of order, but the biggest exponent I see is 3. Okay? Now, once we go bigger than 3, we don't really have special names. If it's bigger than 3, so that would be like, let's say bigger than 3, we're going to call it a blank degree polynomial. And this is going to be like 4th or 5th or 6th. And that number is going to be based on what the exponent is. So for example, let's say we have x to the 4th plus 2x to the 3rd minus 4x. This is a 4th degree polynomial because the biggest exponent I see is 4. Okay? So that's the first name. So this, by degree, is its first name. Okay? Its last name is going to be number of terms. Number of terms. Okay? So if I have 1 term, we're going to call it a monomial. Okay? So like 2x or 5 or 8x to the 12th. Okay? Anything that just has 1 term. Okay? Then let's say it has 2 terms. We're going to call that a binomial. Okay? So like 27 minus 16x or 12x, whoopsie, minus 3x squared. Okay, those are both binomials because if I separate them into terms, I've got 2 terms in each of them. Okay? If it's got 3 terms, we're going to call it a trinomial. So that would be like 8x squared plus 3x minus 6x to the 7th. Okay, it's got 3 terms. It's kind of crazy looking, but it's got 3 terms. And then if it goes any bigger than 3, so we're going to say n is bigger than 3, we're going to call it a polynomial with blank terms. And that's going to be like 4, 5, 6, etc. So, for example, let's say we had x to the 4th plus 2x to the 3rd minus 4x plus 1. Okay, we would call that a polynomial with 4 terms. Okay, because once it gets bigger than 3, we don't have special names for it. Now, so that's how we name them. That's the first name and that's the second name. So let's take a look at some where they're already combined and let's see what we would call them. So let's say we have 12x minus 3x squared. Okay, so its first name is by degree and its last name is by number of terms. Okay, well the highest exponent I see here is a 2, so it's quadratic. And it's got 2 terms, so it's a binomial. Okay? Let's look at this one. 2x squared. Well, let's say 2x to the 3rd, okay? 2x to the 3rd, okay? The highest exponent I see is 3, so that makes it a cubic. The number of terms is 1, so it's a monomial. So this is a cubic monomial. Okay? How about this one? This one's kind of be a mess, but x to the 5th plus 2x to the 3rd minus 4x plus 1. Okay? The highest exponent I see is 5, so it's a 5th degree polynomial. And it's got with 4 terms. Okay, that one was kind of long. That's kind of like the longest way you'll have to write it. Now, I want to show you this one because this one's interesting. 8x squared plus 3x minus 6x to the 7th. And we had this one on the other page, okay? So the highest exponent I see here is 7. So this is a 7th degree polynomial. And there's 3 terms, so it's a trinomial. Now, polynomial is a general term. That's like calling something a quadrilateral when it's got a special name already. It's so like this thing right here, okay? This is a rectangle, okay? That'd be like me calling this a quadrilateral rectangle. It's just a rectangle. So whenever it's already got a special name based on number of terms, we don't call it polynomial. So this is actually a 7th degree trinomial. That make sense? Now, the last thing we want to talk about, and we can use this as an example. When we list quadratics, when we list any polynomial, standard form of a polynomial has us listing it from the highest order exponent to the lowest order exponent. Okay? So if I look at this, what is the highest exponent I see? Well, I don't even see an exponent here, so I'm going to put my invisible 1 there. My highest exponent is 7. So I'm going to do negative 6x to the 7th. Then my next highest exponent is positive 8x squared. And my lowest exponent is positive 3x. This is standard form, going from the highest exponent to the lowest exponent.